Hello explorers! Today we're going to do some science sketchnoting on Punnett squares and pedigrees. So grab your favorite shade of chartreuse, aquamarine, or razzmatazz, and let's get sketching. The title of our sketchnote is Punnett squares and pedigrees. Got a nice little box around there. And the key idea in this is how our patterns of inheritance studied. We're going to have two definitions we're going to start off with. We're going to start off with the definition of the Punnett square. The Punnett square is a graphic used to predict the results of a genetic cross. And our definition for a pedigree is a diagram that shows the occurrence of a genetic trait in several generations of a family. Cutting it close there. All right, so let's put a little bit of color in here, and we're going to put some, it's going to represent flowering pea pods, right, that Gregor Mendel studied. He was studying his inheritance. Make a nice little lavender color. Okay, so let's look at what a Punnett square looks like. And we're gonna go to my front yard for a second, where it's beginning to show signs of spring, and I have all of these lovely tulips planted. I love tulips, especially I love the color of red tulips that come up. So we're going to do a Punnett square on the red tulips in my front yard. Okay, what is the likelihood of that happening? So there's my tulip, and here's my Punnett square that I'm going to do. So we are going to imagine that this tulip right here, the alleles for this tulip are big R, little r, right? And R means it's the red flower allele. capital R, and lowercase r is the white flower allele. So for this tulip, we put the alleles of the one parent up top, big R, little r, and the alleles of the other parent on the side. Okay, big R, little r. So again, this is the alleles. Oops, I need an E in there. Of parent 1, go up top, right? And the alleles of parent 2 are along the side. Right here. Now, if we have big R possibilities, right? Because Punnett squares are we're predicting what's the likelihood of this happening. So we have, in this column, we have 2 big R's. So for sure, this is going to be a red flower. And we're assuming right now that red is complete dominance. And we're going to assume that white is recessive. And that means it doesn't matter if I have a little r, right? If I have the capital R, if I have the complete dominant, the dominant gene, that phenotype will be red. So the genotype is 2 capital R's here, capital R, lowercase r, and then 2 lowercase r. That's the genotype, right? The genotype. That's the genotype. Now what's the color then going to be? Well, since I've got 2 dominant alleles, I'm going to have a red tulip here. Right? I have 1 dominant allele and 1 recessive. I'm still going to have a red tulip, again, because we are assuming complete dominance. And again, 1 dominant allele, 1 recessive allele, red tulip. Aha, but what happens over here, right, with my 2 recessive alleles? That's going to give me a white tulip. Okay, that'd be a white tulip. Right, yeah, went in there. Okay, so let's think for a second here that this, the Punnett square, what it's really doing is showing all of the possible, right? Shows all of the possible allele combinations. In the offspring. All right, we're going to add just a little bit of color here. We're going to add some leaves. So how can you tell which allele is dominant and which allele is recessive just by looking at a Punnett square? Well, hopefully you realize that we can tell which allele is dominant by which allele is capital, right? Capital R. And we can tell which allele is recessive by which allele is lowercase. And they're always going to go in the order of capital, lowercase, or dominant, recessive. All right, so your work to do is you're going to imagine that I've got a red tulip with 2 dominant alleles, 1 parent, right? It's crossing. The parent has 2 dominant alleles for red, crosses with the tulip, with 2 recessive alleles for white. And in this chart, in this Punnett square, I want you to write in the genotype and the phenotype. So remember, the genotype is the combination, right? Capital R, for example, capital R. And the phenotype is the color. And again, you're going under the assumption that red is complete dominance and white is recessive. So fill out that Punnett square. Right, what would the genotype be for a cross between a red, two capital R's, tulip, and a white, two lowercase r's, tulip? Okay. Now, I have another question for you before we move on. If all offspring remember, these are a combination of possible offspring from having two different parent combinations here. So if all offspring are recessive for a trait, so if all my tulips are white, for example, okay, for a trait, like for example, are white, in this instance, my white tulips, what must be the genotype of the parents? Both parents. Right, of both parents. And write your answer for that question right there. Okay, so let's talk a little bit about probability. What is probability? Well, probability is the likelihood that a possible future event will occur in any given instance of that event. So let's take again, let's look at our tulips. Okay, again. And so, a little person here is saying the probability of a red flower is what? Probably of a red flower. If I look up at my Punnett square right here, what is the probability that I'm going to get a red flower? 3 to 4, right? 3 out of 4 of those flowers are red. So 3 out of 4 or 75%. So look over here and we got this person who says yes, and the probability of a white flower is what? If we look at our diagram again, how many of these are white? Just one, right? So 1 to 4 or 25%. Try to get that speech bubble around here. Hard. If we were to put it in a graph, we could go like this, right? Divvy it up. Oops, that's not the way I want to divvy it up. And red. So we have 50% likelihood. This is the combination. We have a 25% likelihood. It'll be that combination and a 25%. I'll make this easier here. So we're going to do a graph. That's what we would do. So that represents 25, 25, and 50. Okay. Let's come back and now let's start talking again about pedigrees. So I need to make a little area here for our pedigrees. Okay. And when we're looking at a pedigree, the diagram, anytime you see a circle, that equals a female, right? Female, chromosomes XX, and the square is a male, XY, right? When we talk about sex-linked disorders, those are disorders that are transmitted and carried on the X chromosome. Oh my gosh, chromosome. Oh. Sorry, I can't read my own writing sometimes. Okay, so let's make a little pedigree down below here. Again, you can cut off your paper a little bit if you want. And we're going to talk about color blindness today. We're going to do a color blindness pedigree. I've actually taught several students who've been colorblind. And in this chart, we're going to refer to an open circle, right? Not colored in, as a normal female. Circle and half colored in, we have a carrier female. If we have a colored in circle, we have an affected female. That means she has color blindness. If I have an open square, that is a normal male. And if I have a colored in square, I have an affected male. Right away when you looked at this, did you think for the second that there's no carrier males? Right? And that's because males only have one X chromosome, right, as we see over here. So that when they inherit the trait, they always exhibit the trait. So here's our pedigree. We're going to start up here. We're going to start with a carrier female. And this line shows a line of marriage, right? Carrier female who gets married to a normal male. They have 3 kiddos. Right, that's what this shows right here, 3 kids. And one is a carrier female. One is a normal female. And one is a affected male. Now their kids get married, right? Mine's right here. And the affected male gets married to a carrying female. The normal female gets married to a normal male. And the carrier female gets married to a normal male as well. Right, so we've got our parents, our first, second, we're looking at our different generations here. And each of these people are going to have kids. So when my normal male and my carrier female have kids, is there a likelihood, or is there a probability that someone could have the gene? Yes, right, because mom's a carrier. They're going to have 3 kids, normal male, normal female, and another carrying female. Okay, so it's not showing up in that side of the family. My normal female and normal male, what's the probability that they will have a affected or a carrying female. Affected male, oops, I meant to put the word male here. Affected male, affected female, or carry female. 0, right? Because no one's carrying any of the traits. So their kiddos will not have the trait at all. And that's because neither mom's not carrying the recessive and dad is not an affected male. Over here, though, we have an affected male who gets married to a carrying female. They have one kid, that's a daughter. Now, because that she has both dad, who's affected, and mom, who's a carrier, in order for females to have the trait, both the mother and the father have to be affected, right? So either mom has to be a carrier and father has to be affected for her to get the allele. And as you remember here, I'm going to put over here again that the allele, the color, I was right, the allele. For color blindness, is carried on the X chromosome. And so for any of these combinations for any of this, we could always go back to a Punnett square to figure out what the likelihood would be. We're just going to go one more down the line here, and this carrying female is married to a normal male. They have 4 kids. First is an affected male. Second is a normal female. Third is a normal male. And the fourth is a affected male. Right? So let's remember that because males only have one X chromosome, sorry. Okay, when they inherit the trait, they always exhibit it. Always exhibit it. So, our main ideas when we're talking here in our little thing today is that both Punnett squares and pedigrees both Punnett squares and pedigrees help you predict the traits that offspring will have based on the parents' traits. Okay, and the key word here is predict. It's not, you're just predicting. You're just seeing what the probability is of a future event happening. And there we go. That's our sketch note. Thanks for sketching with me, explorers. I'm looking forward to seeing your work. Remember, keep exploring. Bye.